right, welcome to the Unit 7 homework packet tutorial. I will be working page 1 and 2 today, and we are working on dimensional analysis in class. Ideally, since the 3rd grade, you would have been seeing customary measurements and metric measurements in your classes. There's going to be different conversion factors for length, volume, mass, and time. So we will be using your chart that you received the day of the test as we go through our first page. Without this as our cheat sheet, it's really hard to do conversions. So I want to focus on the first problem. The first few problems will be a little bit easier because we put the units in to help you know which conversion factor to use. So when we read a problem, the first thing I want you to do is I want you to find the number, and I want you to make a little circle around it. That's going to be called our given. Every problem we will be given a number and a unit. We will always write our given as our first step in the T-bar, 26.2 miles. Now, some teachers will tell you you can leave this blank, some teachers will tell you you can put an X, and some teachers tell you you can put a 1 underneath here. All of those would essentially be the same thing. In physics, we might convert miles per hour to kilometers per hour. So you might use both sides. But for our purposes in chemistry, this will always be blank, X'd out, or a number 1. It does not affect your problem. So we're starting in miles. We also need to look at what the question is asking us. This question in particular says how many feet. So the last thing that we'll have for our conversion factor would be feet at the top. So we gave you the hint that the first thing you're going to have to do is convert miles to yards. So you will look on your length conversion chart and it will say miles. In 1 mile, so I'm just matching up 1 mile, is equal to 1,760 yards. So 1,760 yards. And then we are not to feet yet, so there's another step. We don't have a conversion factor that goes straight from miles to feet, so we ended up going miles to yard, and then we'll do yards to feet. In the next conversion factor, you'll see 1 yard is equal to 3 feet. Oh, I almost wrote feet, but it's right there and already written out for us. So now our problem is officially set up. We have 2 conversion factors. And to solve for our problem, we are actually going to multiply the top and divide by the bottom. I'm going to put my calculator out here, clear it. 26.2 times 1760 times 3 would give us 138,336 feet. And technically everything on the bottom was 1. So if you divide anything by 1, it's the same thing. So that would actually be our final answer. Now you might hear your teachers say, don't forget Sig Figs, make sure your answer's in Sig Figs. And Sig Figs are pretty easy. You look back at the problem and you see how many numbers are significant in the problem. I see 3 different numbers, so my answer will need to be in 3 significant figures. Right now my answer has 1, 2, 3, 4, 5, 6 Sig Figs. So to shorten this up, I would take the first 3 significant numbers I see and I would drop everything else to 0. So we're just rounding it basically to the first 3 significant figures, and that 3 is not big enough to round that 8 up to a 9, so I will leave it just as is. So that would be our answer in significant figures. I prefer my students show me both answers so that if something goes squirrely in the significant figures, I can figure out where the mistake was made. I'm going to go ahead and skip the next one because the units are already there and it will be mirrored very similar to this. You have the units as a guide to help you with your conversion factors. I'm going to do one without any conversion factors, so I can guide you on how to come up with the conversion factors on your own using this chart. Again, the first thing we want to do starting any problem is figure out what our given is. In problem 3, my given is 1.05 liters. Then I would go through the problem and find out, well, what do they want me to change it to? And in this problem, they want us to change it to quarts. So I will actually have to look at my volume. So I'm going to fold my paper to get that distance out of the way for us. And these are my volume conversions. Now, they want us to go to quarts, but we don't have anything straight from liters to quarts. The only thing we can do with liters is go to milliliters or go to gallons. So what we're going to have to do is we're going to have to, since we're going from metric, see how liters is on the metric side, and we're going to customary, we're going to have to use this 1 gallon equals 3.79 liters. So unfortunately, this is going to be a two-step problem because there's nothing that goes straight from liters to quarts. In order to get rid of liters or cancel out liters, we're going to have to put liters on the bottom. And since this is our only switch from metric to customary, we're going to have to put gallons on top. And you could just write GAL for short. So in 1 gallon, you have 3.79 liters. Now this does not finish the problem because we're not in the units that the question asks about. Do we have a way to go from gallon to quart? Let's see. 1 gallon is equal to 4 quarts. So if our ultimate goal is to have quarts, we need a conversion factor from gallon to quarts, which we have right here. 1 gallon is equal to 4 quarts. Just like on the first problem, we're going to have to multiply everything on the top and divide by what's on the bottom. I also want you to know that many of your teachers are mentioning that the units cancel. You'll see that the liters cancel liters. It's a disco method. It's whatever's here, the unit down here should be canceled out. Whatever's here, the unit down here should cancel out, leaving you with only the unit that you're looking for in the question. So I'm going to grab that calculator, and the top, I'm going to go 1.05 times 1 times 4. And most of you know anything times 1 or divided by 1 is the same thing, so I really don't show the calculating times 1 because it's a step you don't have to do. So 4.2 is what I get on the top when I multiply, multiply, multiply. And then I'm going to end up dividing by 3.79 times 1, which is 3.79. So essentially all you have to do is divide the number we just got by 3.79, and my answer would be 1.1081, and a lot of numbers past that. But keep in mind, your teacher's going to want to see you do it in proper Sig Figs. Going back to the problem, we have 3 significant figures. So to go ahead and get this one in 3 significant figures, we would pick the first 3 numbers, and then it's like we're splicing off the rest of the numbers. So that this would, our final answer would be 1.11 quarts. Now you're probably shaking your head going, well, where'd that 0 go? This 8 is actually large enough to round that 0 to the next number. So that's why this is 1.11. Okay. I hope y'all are having a blast. Let's move to the next couple problems. Okay. I'm going to go back to mass. Actually, we haven't done a mass problem yet. So I can tell this is mass because it has pounds and grams. So essentially, what we're going to be doing here is we're going to look at our given. Our given is in pounds. So I'm going to fold my formula sheet to where all I have to really look at is this section here. This is all I have to work from for mass. Pounds and grams. Now you'll notice pounds is over here, grams is over here. So we're going to have to go through the customary to metric conversion factor, which is why they're showing us those separate steps. We always write our given on this first line. And again, I forgot to show this in the last one. You can either put a 1 here, you can put an X here, or you can just simply leave it blank. It's whatever your preference is, or if your teacher prefers one way over the other. It really doesn't matter if this is left blank, X'd out, or you put a 1. It will not alter your mathematics. Since I wrote pounds here, I would have to write pounds on the bottom. Is there a conversion straight from pounds to grams? Well, that would be nice if that were true. So now we have to find some other method. Ounces would not help us either because there's no ounces to grams conversion. So essentially, if we're starting in pounds and we want to go to metric, we have to pick this conversion factor. 1 pound is equal to 0.45 kilograms. This is the customary to metric flip. We know that kilograms is not what our answer is asking for. Our answer is saying, well, how many grams is that? And now we have to find a way to go from kilograms, because we canceled out the pounds. We're done with pounds. So we have to go from kilograms to grams. Since I have kilograms here, I'm going to write kilograms here. Disco method. Whatever's right here has to cancel there. So the only conversion from kilo to grams we have is right here. 1 kilogram is equal to 1,000 grams. So now we're ready to put it in the calculator. Multiply the top and divide by what's on the bottom. Now we're lucky on this problem, everything on the bottom is 1. So essentially, once we multiply, we're going to have the answer. 25.2 times 0.45 times 1,000 would give me 11,340 grams of Smarties. So there were three numbers that were significant here. So that's how many your teacher would like to see in your answer for significance. So I would take the 1, the 3, and I'm splicing it off there. So we end up with 11,300 grams. Alright, I'm going to skip the one where the conversion factors are drawn in for you. And for the rest of the tutorial video, I'm not going to give you the answers. However, I will show you where in the T-bar the things go, so that essentially you're doing your homework and you're just making sure your conversion factors are in the correct place. So I'm going to start with number 6 here. Dr. McLeod walked 204 yards to use the restroom between classes. 204 yards is my starting point. So I'm going to write yards down here because that's the only thing I can to cancel out here. We're in length again, so I'm looking at just this little section here. Okay. It would be amazing if there were a conversion factor between yards and centimeters, but I'm pretty sure, judging by the multiple steps here, there's not. So let's look at what could help us the most. So ultimately we're trying to get to centimeter, and we're starting in yards. Okay? Well, this is not going to work out for us very well because we need to go from customary to metric. However, yards is not anywhere in going from customary to metric. So what we're going to do is we're going to actually have to change this to either feet, so we could change feet into meters, or we could change our yards into inches. It doesn't matter which one you use. So I'm going to go ahead and show you guys how to change the yards into inches, and then we'll do inches into centimeters. I actually prefer this method, but I'll show you another alternative method you could do for this problem in just a moment. So my idea is that I'm going to turn yards into inches. Again, I don't have a conversion factor for yards to inches, so I'm going to put feet up here as kind of a middle step. Because once I get feet, I can change feet into inches, and that would get me here, and then I can change inches straight into centimeters. So it takes practice and a little bit of just thinking about what units you have to convert from and what your plan is and how you plan to execute it. There's generally maybe 2 different ways you could solve this problem. I'll show you a second one in a moment. So you've got yards canceled out. We know that 1 yard is equal to 3 feet. We know that 1 foot is equal to 12 inches. And we know that 1 inch is equal to 2.54 centimeters. You'll notice that the disco method, we're canceling out our units. Feet cancels out feet, inches cancels out inches, so that we're left with centimeters on the top. I will work the answer on this one because the second method has kind of a different answer, but I'll show you what I mean by that in just a minute. So my answer is 186.53, sorry. And of course we want to make our Sig Figs match, so we want 3 because there were 3 significant figures in the problem, so it would be 187.00. So 18,700 centimeters would be our answer in significant figures. Now I want to mention that I just told you there's a second way to do this problem. So I'm going to get a blank sheet of paper out and I'm going to show you the alternative way. Okay. Since there's no room right here, I'm actually just going to put some post-it notes here and I'll show you what else you could have done. Okay. Alright, so essentially we would still have the 204 yards as our given. But the idea was that you could go and flip meters into feet, or feet into meters. So you would still have 1 yard is equal to 3 feet, but then you could say 3.28 feet is equal to 1 meter, and 1 meter is equal to 100 centimeters. .204 times 3 times 100 divided by 3.28 gives me the answer 18658.53. Now you're probably looking at this going, but that gives me a different answer than what we got originally with this method. Shouldn't they be the same? Okay. This conversion factor, the second one we added, is not an exact conversion factor like the 2.54 is. However, we are going to put this number in significant figures like we did here, oops, centimeters. And you'll notice once it's in Sig Figs, I'm sorry I put the comma in the right place because talking and writing is challenging, I suppose. Once I put the answer in significant figures, it takes care of that precision in measuring. So either way you would have worked this problem, you would have got the same answer in Sig Figs. We would never give you a test where we would do both methods and quiz you over one or the other. So at this time I'm going to do just a few more setups just to show you how to set it up. The question I get asked a lot is, how long is a T-bar? How should I make it? I don't know until I get in the problem. I got to kind of be dirty with it and say, all right, it depends on what I have and what I am looking for. So in this problem, I have 2 pounds. As soon as you get what you have and what you're looking for, that's when you pick this up and you're like, all right, we're in math. This is all I have to work with. These are the only conversion factors we'll have to work with, and you will get a copy on this test. I'm going to put a decimal there so I don't think that's 21 later. Sorry, that's just my own brain working there. All right, so on this list, we know we have to have pounds here, because that's what we're starting with. But do we have a pound to kilogram conversion? That's the question. Pound to ounces doesn't help us. Sweet. You guys are going to like this problem because it's one step. 1 pound is equal to 0.45 kilograms. The pounds will cancel. You're left with kilograms. So all you would have to do is multiply those top 2 numbers. Easy peasy on that one compared to the other ones. Okay. All right. I'm going to do number 9 because I think it's interesting and relevant, and the fact that we give you a conversion factor that is not on your chart. Okay. A student was absent for 12 class periods. If one class period is 1.5 hours in length, none of the absences were on Eagle's Nest days, so they were all 1.5 hours in length. How many minutes of class were missed? So we are asked if they missed 12 class periods, how many minutes is that? Okay. So our only given is 12 class periods. We don't have a conversion factor for time for class periods, so we're going to have to use the conversion factor that was given in the problem. 1 class period is equal to 1.5 hours. Now we're done with class periods, and now it's just an hour to minute conversion. So I got to put hours down here, and in 1 hour, we want to find minutes, 60 minutes. So we canceled out our hours, and we're left with minutes. So 12, well, I told y'all I would make y'all calculate it, so I'm going to leave that there for y'all to figure out. But just like every T-bar we do, we multiply the top, and we would divide by the numbers on the bottom. I have not done a liter conversion in a while, so I'll go ahead and do one more of those for y'all so y'all can see the volume, and then I'll show you the bottom part. Okay. If I bring 1 gallon of Gatorade to class, how many 1-cup servings could I hand out to my students? This is a challenging problem because students ask me, well, what's the given, 1 cup or 1 gallon? I want to know how many servings I can bring, and the servings need to be in cups. So my given is actually 1 gallon of Gatorade. Okay. And looking at the volume, I don't have a gallon to cup conversion. Now everything is in gallon and cup is still customary, so I will not need metric at all for this problem. So these are the conversion factors we'll use. The only thing we have here is gallon is equal to 4 quarts. So 1 gallon is equal to 4 quarts. Okay? So we're done with gallon. But now we're kind of stuck at quarts. I don't want to know how many quarts. I want to know how many cups. Do I have a quart to cup? No. All I have is a quart to a pint. So 1 quart is equal to 2 pints. I still don't care about pints. I want to know cups. So I draw another line. What we did in this step was we canceled out the quarts to give us pints. And in our final step, for every 1 pint, that's equal to 2 cups. So we're getting this nice linear way to cancel out units and know how to multiply and divide to get the proper units. Okay. So 1 times 4 is 4, times 2 is 8, times 2 is 16. So I could actually make you know what I did? 1 gallon is 4 quarts, 1 quart is 2 pints, and 1 pint is 2 cups. Okay. 1 times 4 times 2 times 2, 8 times 2 is 16 cups. All right. Now most of that came from your 3rd grade mathematical reference materials. We wanted to go over how to use dimensional analysis to help you with things in your past that you're already familiar with. In chemistry, our most famous conversion factor is converting from moles to atoms or moles to grams. So on the rest of these worksheets, the rest of this worksheet, you're going to use this conversion factor. You will not even need your 3rd grade math reference because we're back to chemistry. We're going to use the same mechanism to put 15.2 moles of calcium sulfide. That's going to be our given. So you start out the same exact way with your given. I'm going to highlight this so y'all can see that we're going to use this on this page. And what it's asking us to do is to convert 1 mole into particles. Now, particle is a generic term. If we're talking about the smallest unit of an element, it's called an atom. If we're talking about the smallest unit of a covalent compound, like water, we would say molecule. And if we were talking about the smallest unit of an ionic compound, like calcium sulfide, we would more properly say formula unit. But since the problem is using the word particle, I'm going to write the word particle up here. So every 1 mole is equal to 6.02 times 10 to the 23rd particles. All of our chemistry dimensional analysis will be one nice easy step. So we're going to multiply these two numbers. In chemistry, we taught you a shortcut using this EE key. On this calculator, I would have to hit 6.02, second EE, 23, And that E simply means times 10 to the power of. So you would not hit times or 10 or the caret thing. And my answer would be 9.1504 times 10 to the 24th. But again, your teacher's going to want to see that you saw that there's 3 numbers here of significance. So we only need the first 3 here. 9.15 times 10 to the 24th particles would be my final answer. Okay. Now the following question has you starting in atoms. 5.69 times 10 to the 23rd atoms. So we're going to end up canceling out atoms. Atoms uses Avogadro's number. And we're looking for moles. It says how many moles? So I'm going to put 1 mole. Because 1 mole is equal to Avogadro's number in atoms. That's what this conversion factor is stating. So again, just like our dimensional analysis on the first page, we'll be multiplying the top and dividing by the bottom. Ooh, that's a lot of scientific notation to type in. No fear if you use the EE key. Second E, 23. Even your cell phones have an EE key. If you are at home and you're using an iPhone, you can simply tilt your phone sideways and this EE key will appear. If you're on a Droid, you can download Wabbit EMU, kind of a weird WABBIT EMU on the Play Store. But the Apple, all you have to do is turn it sideways. And on a Droid or Samsung, you go to the Play Store and you find Wabbit EMU and download a graphing calculator. They're free, so there's no sense in not having a nice graphing calculator. Once we divide those two numbers, we get 0.945182, yada, yada, yada. But we only need 3 numbers of significance because that's how many are in our original problem. So I'm going to cut it off right there. 0.945 moles would be our final answer. I hope this has been a helpful tutorial. If you need any more help, you can come in before or after school. We have tutorial times every day of the week, Monday through Thursday, and I am here before school. I'm Miss Hanson, and I'm here before school every morning at about 6:30 for your convenience. If you have any other questions or need any additional help, there will be some more tutorial videos to come. But basically tomorrow night's assignment, which Ms. Holm has graciously offered to host, she will be doing more conversions with the one we learned today, as well as with molar math. So keep in mind there's always homework help for you guys. It's just if you will use it. I appreciate you listening. It's been a long 33 minutes for you, so thank you very much for your time.